Hi, my name is Maria Rivera and I'm going to be talking about the public lecture I attended for physics, which is 1,000 years of Einstein's gravity and inquiring minds. And what they basically talked was that the gravitational field has only a relative existence, because for an observer freely falling from the roof, at least in his immediate surroundings, there exists no gravitational field, so gravitation equals acceleration. And some of the consequences of the general relativity principle is that, for example, a man who's standing motionless with a clock, and then someone is holding a clock on a moving shuttle, so if someone grabs a rocket and takes it to space and then returns, his clock will have a different hour than the person on the ground, which makes him younger than the other person. And another thing that she talked about is that a person at the top of a building ages more than a person at the bottom of the building. The second thing she talked about is black holes. And we saw in a very interesting animation of a black hole that one of the interesting things that she said is that you can't really know that a black hole exists. A black hole itself has never been detected, and it's impossible to detect it. But you can detect its interactions with the matter around it in space. So we saw a video where a star was colliding into the black hole, and it was basically being sucked into it slowly as if matter was detaching from the star and into the hole. She also said that black holes are at the center of the galaxies, such as our Milky Way. There's a black hole in the middle. We talked about spaghettification, which is that if you get close enough, it forces you to stretch out. And the life cycle of a star is to get to a black hole starts as a stellar nebular, then a massive star, then red supergiant, a supernova, and then it continues. Finally, we talked about gravitational waves, which are the ones that come out of the black hole. And these are measured by the Laser Interferometer Gravitational Wave Observatory, which is the long way of saying LIGO. And so the initial LIGO measured 100 galaxies, but they advanced it, and the new one will be able to measure 100,000 galaxies. And this new one will resume its search for gravitational waves this September. So in general, we talked about how gravitational works in Einstein's field equations, but we also talked about other field equations and what their implications are, so not only E equals mc squared. The public lecture as a whole was very interesting, and I hope the students next semester are able to have such interesting talks.